All right, so you want to know all about mean, median, and mode. But when the data is kind of, well, grouped together, like not just a simple list of numbers.
Exactly. Yeah, think about it. Like, you've got responses to a survey from, I don't know, thousands of people.
Oh,
You
yeah.
wouldn't want to list every single answer. Too
No.
much. Way too much.
That's where this deep dive comes in, right?
Right?
We're looking at how these ideas mean, median, mode work when you've got tons of data organized into categories.
Right, into those groups.
We're using a Class X mathematics textbook as our guide here.
Solid foundation.
So we're starting with something reliable, and then we're going to see how to actually use these calculations to get some real insights.
Yeah, more than just an average, you know. We're going for the good stuff, the real understanding of what this group data can tell you.
All right, so let's start with the mean,
The classic average.
yeah, I always think back to that basic formula, like add up all the numbers, divide by how many you have.
It's a good starting point.
And our textbook starts there too, reminding us that for ungrouped data, it's the sum of each value times its frequency,
Right, so how often it appears.
all divided by the total number of observations.
The sum of all those frequencies makes sense for simple lists, you know?
For sure.
But like we were saying, imagine that with a huge data set.
Oh, yeah.
It wouldn't work.
No.
So that's where these class intervals come in.
Okay. Yeah, those ranges, the buckets.
Exactly. So instead of listing every single age, you might have a group for people from 20 to 30, then another from 30 to 40, and so on.
Makes it much tidier.
And the textbook actually mentions a helpful rule here. If a value falls right on the upper limit of a class, it's usually included in the next higher interval.
Oh, I see.
So someone who is exactly 30 years old would go in the 30 to 40 group, not the 20 to 30 group.
Makes sense. Keep things organized.
Yeah. Avoids any confusion.
So we've got these ranges, these neat little categories.
Right.
But how do we actually calculate the mean when we don't have the individual values anymore?
Good question. That's where the class mark comes in.
Class mark.
Think of it as the representative value for everyone within that class interval.
A stand-in.
Yeah, exactly. And it's simply the midpoint of the class.
So you add the upper and lower limit and divide by 2?
Exactly. So for that 20 to 30 age group, the class mark would be 25.
Got it. So everyone in that bucket is, for our calculations, 25.
Exactly.
Now, the book calls the first method for calculating the mean the direct method, straightforward name.
It is pretty straightforward. Yeah, you're basically extending that basic mean formula.
Okay.
So instead of summing up all the individual data points, we're summing up the product of each class mark and its frequency.
So how many people are in each age group in our example?
Exactly. And then we divide that sum by the total number of observations.
Sounds familiar.
Yeah, the formula looks the same. But remember, now those X are our class marks, not the individual data points.
Makes sense.
The textbook shows this with, let me see, table 13.3.
Okay.
It's an example with student marks.
Oh, good example.
Yeah, you can see how it all works.
But it is worth pointing out, right, that this mean we get from group data might be a little different than if we had all the original ungrouped data.
Right, because we're using that midpoint, that class mark, as a stand-in.
Yeah.
It's a good approximation, especially with a lot of data, but it's not going to be perfect.
Right, a good estimate.
Exactly.
Now, the book also talks about this assumed mean method.
Ah, yes.
Why do we need another way to calculate the mean?
Well, sometimes those class marks and frequencies, they can get pretty big.
Oh, yeah, I can see how that could get messy.
This assumed mean method, it's a trick, really, to simplify those calculations.
The shortcut.
You got it. The idea is to pick one of your class marks as a kind of starting point.
Okay.
We call it the assumed mean, and it's usually represented by the letter A.
All right, so pick a class mark, call it A.
Then for each class, you figure out how much its class mark differs from this assumed mean.
Okay, so the difference between each class mark and our chosen A.
Right, we call that difference die, so die equal I, and this gives us a new set of numbers to work with, these deviations, which are usually smaller than the original class marks.
Interesting, so we're shifting our focus.
Kind of, yeah. We're looking at how far each group is from this assumed mean.
And how does that help us get to the actual mean?
So you calculate these deviations for each class, right?
Right.
You multiply them by their frequency, so funny. Then you add up all those products.
Okay.
That gives you Edfen.
Offenda.
The actual mean of your data, we represent that as X, is then your assumed mean, A, plus the average of those deviations.
So A plus Fn.
You got it. And you can see this in action in table 13.4 in the book. They walk through an example.
I like how they have those tables to show us.
Yeah, it makes it a lot clearer.
And I can see how picking a class mark somewhere in the middle as your assumed mean
Right, somewhere central.
would make the calculations a lot easier.
Smaller numbers, always easier to work with.
Definitely.
Less room for errors.
Now, there's a third method, too, the step deviation method, which sounds even more,
Even more simplified.
yeah.
This one is particularly useful when those deviations we just talked about, when they have a common factor,
Okay.
which often happens when your class intervals are all the same size.
Right, like all those age ranges being 10 years.
Exactly. We call that size h, and in this method, we bring in another variable.
Another one. All right.
It's basically the deviation, that sine, divided by this common factor,
So we're scaling things down even further.
Yeah, we get even smaller numbers to work with, often single-digit numbers, which makes the math much easier.
I like where this is going.
The formula for the mean using this method is a plus or a fen.
Okay, so we calculate those values, multiply by the frequencies, sum them up, divide by the total frequency, multiply by h, and add back our assumed mean a.
You got it.
And the beauty of it is, all three methods should give us the same answer for the mean, right?
Exactly. It's just about choosing the method that's easiest for the specific data you have.
If the numbers are small, maybe the direct method is quickest.
Yeah. But if they're large, those other two can really save you some headaches.
Love a good shortcut.
And example 2 in the book actually shows all three methods applied to the same data about female teachers, I think.
Oh, perfect.
And they all end up with the same mean, 39.71.
Proof that they all work.
Exactly.
Now, the book also looks at an example 3, about wickets taken by bowlers.
Oh, yeah, cricket.
And in this one, the class sizes aren't all equal.
Right, they vary.
And the class marks themselves are pretty big numbers.
Makes things a bit trickier.
They still manage to use the step deviation method, though, by cleverly choosing a common divisor.
Right, a common factor for those deviations.
So even when the class intervals aren't perfectly uniform,
You can still find ways to simplify the calculations.
and the mean they get in that example gives us that average number of wickets taken by a bowler in that group.
Exactly.
Gives us a sense of the central tendency of that data.
Typical performance, yeah.
Typical performance.
Yes.
Now, the book mentions a couple of exercises, 13.1 questions 1 and 2, which I'm guessing gives some practice with these mean calculations.
Definitely. Good way to test your understanding.
All right, so we've tackled the mean.
Conquered it.
Let's move on to the mode of grouped data.
All right, the mode.
Now, with a simple list of numbers, the mode is just the number that shows up most often, right?
The most frequent.
But with grouped data, we don't have those individual numbers anymore, so how do we find the mode then?
Yeah, it's a bit different. We can't just look for the most frequent value because everything's bundled up in those classes.
Right.
So instead, we find the modal class,
Which is?
the class interval with the highest frequency, the most popular range in your data, basically.
Okay, so it's the range with the most occurrences.
Exactly. And then the mode itself is a specific value that we estimate within this modal class.
So we need a formula for that.
We do, and it looks like this. Mode L plus FAU 2 FF FFH.
All right, break that down for me.
So FS is the lower limit of the modal class. H is the width of the class interval. And this formula works best when all your class intervals are roughly the same size.
Makes sense.
Then we have 8, which is the frequency of the modal class itself.
The number of data points in that most frequent range.
Right. AF is the frequency of the class before the modal class, and F is the frequency of the class after the modal class.
All right, so we're looking at the frequencies around the modal class, too.
Exactly. It all influences the calculation.
The book has an example, example 5, dealing with family sizes, which helps to see this in action.
Yeah, a good illustration.
So you scan those frequencies, find the highest one, which in that case is 8.
Corresponds to the family size range of 3-5.
So that's our modal class.
Right, 3-5 family members.
And then you plug all those values into the formula, the lower limit, the class size, the frequencies.
And you get a mode of 3.286.
Interesting. So even though the most popular range was 3 to 5, the formula gives us a more precise value within that range.
And it's influenced by those frequencies around it, how they drop off on either side.
Now, the book also goes back to the student marks example, example 6.
Ah, yes.
This time, the modal class is 40-55.
Highest frequency there.
And using the formula, they get a mode of 52.
Okay.
And then they do something really interesting. They compare this mode of 52 to the mean they calculated earlier, which was 62.
Ah, yeah, that's a key point.
because it shows us what these different measures actually tell us.
Right, they're giving us different insights.
So the mode of 52 tells us that the score that popped up most often was 52,
Exact.
while the mean of 62 represents that average score when we consider all the scores together.
Right, they can be different, and that difference tells us something about the distribution of the data.
The mode highlights the most common occurrence, while the mean balances everything out.
Exactly.
And as the book points out, the mode can be lower than the mean, equal to it, or higher than it.
It all depends on how the data is spread out.
And it's important to think about what you're actually trying to find out, right?
Yeah. For sure. If you're a manufacturer, let's say, and you want to know the most popular shoe size to make,
Yeah.
the mode would be way more useful than the mean.
You want to know what's selling.
Exactly.
The book then suggests working through exercise 13.2, questions 1 and 2, to practice with the mode.
Good practice.
All right, we've done the mean, we've done the mode. That brings us to the last one. The median.
The middle ground.
With a simple set of numbers, the median is just the middle value.
Right. So you put them in order.
If you have an even number of values, it's the average of the two middle ones.
Right.
But how does this middle idea work with grouped data?
Well, the idea stays the same. The median is still the central point.
Okay.
But finding it with grouped data, yeah, that takes a few more steps.
All right, walk me through it.
So for ungrouped data with frequencies, like in table 13.11 in the book, we use the cumulative frequency to find those middle observations.
Cumulative frequency, that running total? Right.
Exactly, like keeping track of how many data points we've seen as we go. So if you have n total observations, the median is at the n+1 position if n is odd.
Okay.
Or it's the average of the n-th n+1th positions if n is even.
Right, so we're pinpointing the location of that middle value.
And this cumulative frequency, it's key for grouped data, too.
Okay, so how do we use it?
We create a cumulative frequency distribution.
Which can be less than type or more than type, the book says.
Right, less than shows how many observations are below the upper limit of each class.
Okay,
More than shows how many are greater than or equal to the lower limit.
got it.
Tables 13.13 and 13.14 in the book show both types using that student marks example again.
Oh, good, familiar data.
Helps to see it in context.
So we build these running totals, these cumulative frequencies, based on our group data.
Right.
How does that lead us to the median class?
So first we find the total number of observations.
Okay.
And calculate N2.
Got it.
The median class is the class where the cumulative frequency first goes above this N2 value.
The class that contains that middle data point.
Exactly. Table 13.15 shows this with the student marks, the frequencies, and the less than cumulative frequencies.
Okay.
There are 53 students, so N2 is 26.5.
Right.
The cumulative frequency that first goes above 26.5 is 29.
Which corresponds to the class 60-70.
Exactly. That's our median class.
So the median value itself is somewhere in that 60-70 range.
Right. And to get a more precise estimate, we use the median formula for grouped data. Median equal L plus N2CF FAH.
Okay, let's break it down.
L is the lower limit of the median class.
60 in our example.
Right. N is the total number of observations.
53 students,
CF is the cumulative frequency of the class before the median class.
which would be 22,
Exactly. The frequency of the class 50-60.
Yeah.
F is the frequency of the median class itself.
which is 7.
And H is the width of the median class interval.
10 in our case.
Assuming those roughly equal class sizes.
Right.
So plugging it all in. Median equals 60 plus 26.5, 22, 7 times 10.
And that gives us,
A median of 66.4.
so roughly half the students scored below 66.4 and half scored above.
That's the idea.
The book has another example, example 7, about heights of girls, where the data is given as a less than cumulative frequency.
Oh, interesting.
So you have to convert that back into regular class intervals and their individual frequencies
Right. Got to undo that cumulative process.
before you can even use the formula.
Exactly. Example 7 shows how to do that.
And then there's a trickier one, example 8.
Oh, yeah, that one with the missing frequencies.
Yeah, represented by X and Y.
But they give us the overall median and the total frequency.
Right, and you can actually use the median formula in reverse, along with the total frequency, to figure out those missing values.
It's a good problem-solving challenge.
Definitely.
Shows how the formula can be applied in different ways.
Now, the book also suggests some practice problems with the median. Exercise 13.3, questions 1 and 2.
Got to put it all into practice.
So we've now covered all three.
Yeah.
The mean, the mode, and the median for group data.
The trifecta.
But the big question is, when do we use each one?
Ah, yes, the crucial question.
When is the mean the best choice? When should we look at the median? And when does the mode make the most sense?
So the mean, as we've seen, it considers every single observation.
Through those class marks and frequencies.
Right. Which makes it really good for comparing different data sets or different groups.
Okay.
But because it considers every value, it can be affected by extreme values, those outliers.
Ah, right. A few really high or really low values can skew the mean.
Exactly. Like if you're looking at average income in a town.
And suddenly a billionaire moves in.
Exactly. The mean income would jump way up, even though most people's incomes haven't changed.
Right. Not very representative then.
Not in that case, no. So in situations like that, where you might have outliers or where the data is skewed,
The median is a better choice,
often, yeah, it focuses on that middle value.
but it's not pulled around by those extreme values.
Exactly. Think about house prices. A few mansions can really inflate the mean,
Yeah.
but the median gives you a better sense of the typical price.
The price where half the houses are cheaper and half are more expensive.
Exactly. It's more robust, more stable.
So the median is our go-to when we want a typical value and we want to minimize the impact of outliers.
Exactly.
What about the mode? When does it take center stage?
The mode is all about identifying what occurs most often.
The most frequent value, the most popular category.
Exactly. So if you're trying to figure out the most popular color for a product,
Yeah.
you'd look at the mode of your sales data.
See what's flying off the shelves.
Right. Or if you're looking at blood types in a population.
The mode would tell you the most common blood type.
Exactly.
So each measure gives us a different piece of the puzzle.
A different perspective.
The mean is that arithmetic average.
Influenced by everything.
The median is the physical middle.
Resistant to those extremes.
And the mode is just what shows up most often.
The most frequent occurrence.
And the textbook mentions this interesting relationship. 3 median equals mode plus 2 mean.
It's an empirical relationship.
Not always perfect, but it can give you a rough idea of how those measures relate to each other.
Yeah, a good rule of thumb.
So, quick recap. We've covered the direct method, the assumed mean method, and the step deviation method for the mean.
3 ways to get to the same answer.
We've learned how to find the modal class and calculate the mode.
Using that formula,
And we've explored cumulative frequencies and the formula for the median.
all for grouped data.
And the key takeaway for me is that these aren't just calculations, they're tools for understanding our data.
Different lenses to see those central tendencies.
And they give us much richer insights than just a simple average could.
It's about moving beyond just crunching the numbers
Exactly. It's about understanding what those numbers actually mean.
and what they tell us about the patterns in our data.
So for our listener, now that you have these tools, I encourage you to think about how you might apply them in your own life,
Yeah, get creative.
whether it's in your work or your hobbies.
Anywhere you see grouped data.
Think about which measure, the mean, the median, or the mode, would unlock the most meaningful insights.
It's about finding the right tool for the job.
And by exploring that, you'll really solidify your understanding and see how powerful these statistical concepts can be.
Make them work for you.
Thanks for taking another deep dive with us.
Always a pleasure.